Dear students, last class we have seen chemical bonding, right? Today we are going to study about Lewis dot structure for simple molecules and polyatomic ions. Okay, let us go for that. So Lewis dot structure. Last video, one small mistake is there. That means last class I written calcium. Electronic configuration 2, 8, 8, 2. For this I written 2, 8, 2. So this is simple mistakes. This is the correct one. Please correct it. Okay. So first Lewis dot structure. Lewis dot structure. Structure for simple molecules. Okay, simple molecules and ions and polyatomic ions. First one, what is the first step? First step is calculate the total number of electrons. Total number of electrons for completing octet. Octet for combining atoms. Combining atoms. Okay. If for hydrogen, it is doublet or duplet, because hydrogen only has 2 electrons, outermost valence shell hydrogen 1, completing octet configuration of helium. Next one, number 2, calculate the total number of valence electron. Total number of valence electrons. Valence electrons. This we can name as T. This we can symbolize valence electron V. Here sub first point, if it is if it is cation, subtract 1 unit charge. If it is anion, add 1 unit charge. Okay. Third point, calculate the total number of shared electrons. That we can call it S. Next one, fourth one, S can be calculated by T minus V. That means S is equal to T minus V. Right? Fourth one is calculate the total number of unshared electrons. Unshared electron we are representing by U. U is equal to V minus S. Okay. Then fifth point is position, or you can write arrange, place the least electronegative atom in the center. More electronegative, high electronegative atom, high electronegative atom can be given at the terminal position. That means here we are giving skeletal structure. This gives skeletal structure of the molecule. Very important point. Hydrogen and fluorine always are in the terminal position. Terminal positions. Final point, sixth point. Arrange all the electrons in the molecule. All the electrons, shared or unshared, or shared and unshared. Unshared electrons. Okay. Now first we are going to see example for methane, right? Okay. Example methane. Okay. First let us calculate T, total number of electrons. T is equal to, for carbon octet configuration 8, for hydrogen duplet. So how many hydrogen are there? 4 hydrogen. So 4 into 2, that means 8. So 8 plus 8 is equal to 16, right? Then second one, V is equal to valence electron of carbon 4. This is for carbon. Hydrogen, for each hydrogen 1, so 4 is equal to 8, right? The next one, TB, then shared electron, S is equal to T minus V, that is 16 minus 8 is equal to 8. This is shared electrons. Then U, unshared electron. V minus S. What is the V? S minus 8 is equal to 0. Okay children, now we see how we'll give the Lewis structure. Carbon, hydrogen. Okay, here how many shared electrons are there? 8 electrons. These 8 electrons we can represent 1 2 1 2 1 2 1 2. Okay, so 8. Here if you see here you will get 2. For hydrogen duplet configuration will come. This also duplet configuration comes. This also duplet configuration. This also duplet configuration. In case of carbon you get 8. Okay, not necessary to draw these lines and everything, only you have to represent by dot. So C 1 2 1 2 1 2 1 2. So hydrogen. This is for methane, right? Same thing. this compound doesn't contain any unshared electron. Now we go for another example, that is for carbon monoxide, right? Another example is carbon monoxide. For carbon monoxide, CO. So total number of electrons for carbon 8. This also 8, oxygen. So total number of electron is 16. Next one, valence electron. For carbon 4, oxygen 6 is equal to 10. Okay, then shared electron. How will you calculate? T minus V. So 16 minus 10 is equal to 6. Unshared electron. Valence electron minus shared electron is equal to 10 minus 6 is equal to 4. So we'll write carbon monoxide, carbon here, oxygen here. Okay, how many shared pair of electrons are there? 6 electrons. So we'll 1, 2, 3, 4, 5, 6. Then how many unshared electrons are there? 4. So 4 you can represent. You see here 6 only. Here this C. So you have to complete octet configuration for oxygen. So 4 electrons are there. 4 electrons should be placed such a way both carbon and oxygen complete octet configuration. So here already 6. So you can put here 2. Here also you can put here 2. So both complete octet configuration. Is it clear? Okay. Now we go for polyatomic ions. This is simple molecules. For polyatomic ions, how will you do that one? For example, CO3 2 minus. Polyatomic ions. First we will do for anions. Anions, you see CO3 2 minus. CO3 2 minus. Right? So here total electrons 8 plus. Here 3 are there. 3 into 8. We have written the rules. If here 2 minus is there, if negative charge is there, what you have to do? Negative charge leads to addition of that particular number. Suppose 2 minus. So here you add, here 3 into 8. So what is answer? 8 plus 24 is equal to 32 electrons. This is the total number of electrons, right? Now in case of valence electron, the charge should be included. Charge on the top, charge should be included. Okay, how will you add this one? Carbon 4 plus oxygen 3 into 6 valence electron. Here 2 minus, so it leads to plus 2. Okay, so what you will get? 4 plus 18 plus 2. So 24 electrons. Okay, this is valence electron. The next, so T over V over. So next one, shared electron. Shared electron is equal to T minus V. So 32 minus 24 is equal to 8 electrons. Okay, now unshared electron. Unshared electron is equal to V minus S. So what is V? 24 minus 8 is equal to, how you are getting 16, I think. 16 electrons. Okay, now we will represent this one in dot. You take carbon. So first we have to write skeletal structure. So in CO3 2 minus, carbon is less electronegative. So you place the carbon here, oxygen here, oxygen here, oxygen here. Right? Now see here how many shared electrons are there? Shared electrons are 8. Okay, 8 shared electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is correct. Then unshared electron, how many? 16 are there. What we can do? Here already 2 electrons are there. Complete the octet. 2, 3, 4, 5, 6, 7, 8. here 2, 4, 5, 6, 7, 8. Here already 4 are there. So 5, 6, 7, 8. So if you calculate the unshared electron, there should be 16. You see unshared electron 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 12, 13, 14, 15. See here 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11. Here one more will come. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Okay. Here 4. So 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4. So 6 plus 6, 12. 12 plus 4, 14. Sorry, 16. That is the 16 electrons. So clear? So what we can do after that, here 2 minus you have to represent now, then you can put the bracket like this. Above this one you can write 2 minus. So how will you write? Here 2 minus here. Okay. So first one you see here, first total number of electrons assuming each combining atoms complete its octet configuration. Then valence electrons. For valence electron, for each atom valence electron plus it is negative ion. So for negative ion you should add the 2 charges here. Okay, after that S is equal to, what is S? Shared electron, T minus V 8. Then U, B minus S 16. Okay, this is anion. Now let us do other example for cations. NH4 plus, NH4 plus, that is carbonate ion. This is ammonium ion. Ammonium ion. I think everybody must be knowing that one. So first one assuming this octet configuration. So total number of electron is, this is 8. For this one 2 duplet. So 4 into 2. So 8 electrons. So 16 electrons. Okay, then valence electron. For nitrogen, what is the valency? 2, 5. So 5 plus hydrogen. How many hydrogen? For hydrogen 1. For 4 hydrogen, 4 electron. Plus, here plus is there. So if cation, subtract the charge. Here 1 unit positive charge is there. So you subtract 1 minus 1. So what you will get? 10, 9 minus 1, 8 electron. Okay, then shared electron. How will you share the electron? Share T minus V. So 16 minus 8 is equal to 8. Next one, what is unshared electron? V minus S. That is 8 minus 8 is equal to 0. Okay, now we can draw the structure. So ammonia, N, H, H, H and H. Okay, so shared electron, how many are there? 8 electrons. So you can put here 1, 2, 3, 4, 5, 6, 7, 8. Unshared electrons 0. So here you see hydrogen 2. This also hydrogen 2. This also hydrogen 2. This also hydrogen 2. This hydrogen H. This total charge here it will become plus. Okay, this is over. Another example. Let us see hydrogen cyanide. Hydrogen cyanide. HCN. HCN. So here HCN, total number of electrons. So T is equal to hydrogen 2, carbon 8, nitrogen 8. So how many will come? 18 electrons. Then valence electron, hydrogen 1, carbon 4, nitrogen 5. So 10 electrons. then shared electron T minus V, that is 18 minus 10 is equal to 8. Then unshared electron V minus S, V minus S is equal to 10 minus 8 is equal to 2. Okay, now children come on here, so we can represent HCN. You see, this is more electronegative, this is also more electronegative, so least electronegative carbon we are writing in the middle, carbon. Then how many shared electrons are there? 8 shared pair, 1 2 3 4 5 6 7 8. Okay, hydrogen, so duplet configuration over, then nothing to added here. Next one, unshared electron, how many are there? 2. You see, while writing you should see whether it is completing octet or duplet configuration. So this is 2. Here what is coming here? 1 3 for nitrogen, 6. So remaining unshared electron 2. You see, unshared electron we are representing here. So here 6 plus 2 8. For carbon 6 plus 2 8. For hydrogen 2. This one 8. This also completed 8. I think you understood this concept. Please practice it. If you practice it, you will get the answer. Okay, very easily you can represent the Lewis dot structure. Okay, children, so first you start writing practice what is Lewis dot structure, then practice for simple molecules and polyatomic ions. I have given one example for cation, anion and simple molecules. Follow the rules properly. Very easily you can write the Lewis dot structure. Remaining we will see in the next video. Okay, thank you.